Imagine this. One ordinary day, you're sipping your morning coffee, scrolling through your phone, when suddenly the sky starts to change. The sun, our eternal companion, begins to shrink in the distance. Days turn into endless nights, temperatures plummet, and chaos erupts worldwide. What if Earth, our blue planet, was suddenly ejected from the solar system? Would humanity survive? How would life as we know it end or evolve? This isn't just sci-fi, it's a chilling possibility rooted in astrophysics. Today, we're diving deep into this what-if scenario. What could trigger such a catastrophe? Why would our stable orbit fail? How would the planet and its inhabitants react? And where would Earth end up in the vast, empty void of space? Let's start at the beginning. Earth isn't just floating randomly in space. It's locked in a delicate dance around the sun, held by gravity's invisible grip. The sun at the center, pulling 8 planets, countless asteroids and comets into orderly orbits. Earth's path is an ellipse, about 93 million miles from the sun on average, completing one lap every 365 days. This setup isn't accidental. It's the result of 4.6 billion years of gravitational fine-tuning after the solar system formed from a swirling disk of gas and dust. But why is this stability so crucial? The sun provides heat, light, and energy that powers everything from photosynthesis in plants to the water cycle that keeps our oceans flowing. Without it, Earth would be a frozen rock. Scientists like those at NASA study orbital mechanics, using Newton's laws and Einstein's relativity to predict stability. Yet, in rare cosmic events, this balance can shatter. Ever wondered what keeps us safe? It's the precise masses and distances. No planet is heavy enough to yank another out. But introduce a rogue element and boom, ejection becomes possible. What could possibly eject Earth? It's not like flipping a switch. The most likely culprits are massive interstellar visitors, rogue stars, or black holes wandering through our galaxy. Our Milky Way is a bustling highway of 100 billion stars, and occasionally one passes too close. In 2018, astronomers spotted Oumuamua, the first interstellar object zipping through our system. But it was tiny. Imagine something bigger, a star like our sun, hurtling toward us at 100,000 miles per hour. How does this work? Gravity slingshots. If a massive star grazes the outer solar system, it could perturb Jupiter or Saturn's orbits first. These gas giants act as shields, but in a worst-case scenario, their gravitational tug-of-war could fling Earth outward like a marble from a slingshot. Simulations from the European Space Agency show that a close encounter within 100 astronomical units, about 9 billion miles, has a 1 in 100,000 chance per billion years. Thrilling, right? But wait, what if it's a black hole? Primordial ones, leftovers from the Big Bang, could sneak in undetected, warping space-time and ejecting planets without warning. Why Earth specifically? It's lightweight compared to giants, making it easier to boot. Let's say a rogue star, dubbed Nemesis in our story, swings by Neptune's orbit. Gravitational chaos ensues. Planets wobble, comets rain in. Earth's orbit stretches like taffy, turning from a circle to a wild hyperbola. Escape velocity from the solar system is about 26 miles per second at Earth's distance. Hit that and we're gone. What happens in those first hours? Alarms blare at observatories worldwide. Astronomers spot the intruder months ahead, but evacuation impossible. As Earth accelerates outward, you'd feel nothing at first. Gravity changes are subtle, but telescopes show the sun receding. Computer models from MIT's Planetary Dynamics Lab predict this. In 10 to 100 years post-encounter, Earth breaks free, hurtling at 100,000 miles per hour into interstellar space. Why so fast? Momentum conserved from the perturbation. Thrilling line, imagine the headlines. Earth evicted, humanity's new nomad life begins. But what about the immediate fallout? Would quakes rip the ground? Tsunamis swallow cities? As Earth escapes, the sun's pull weakens. First signs, tides slacken. The moon, tidally locked to us, might wobble but stays. Its orbit around Earth is independent. But satellites, chaos. GPS fails as orbits decay without solar corrections. Power grids blackout from solar wind disruptions. How does this affect us? Earthquakes spike from gravitational stress, cracking continents. Volcanoes erupt as mantle pressures shift. Scientifically, a 2019 study in Nature Astronomy modeled this. Tidal forces could trigger magnitude 10 quakes, far beyond anything recorded. Why thrilling? Because it's not instant doom. It's a slow build. Temperatures drop slightly at first. What happens when the sun becomes just a distant star? Weeks turn to months. The sun shrinks to a pinpoint, like Venus at dusk, but fading forever. Daytime vanishes, perpetual twilight reigns. Photosynthesis halts, plants wither, oxygen production crashes, humanity scrambles, greenhouses with artificial lights. But for 8 billion people, impossible. Earth receives 1,368 watts per square meter from the sun. Without it, surface temperature plummets to -240 degrees Celsius, colder than Pluto. But it doesn't happen overnight. Earth's oceans and atmosphere act as heat batteries, delaying the freeze by years. A NASA simulation estimates first year average temp drops 10 to 20 degrees Celsius. Thrilling narrative, refugees huddling in underground bunkers, rationing food as auroras, now from cosmic rays, light the sky. How long until ice engulfs everything? Why might some life persist? The polar ice caps spread across the planet. Europe and North America vanish under thick sheets of ice. Oceans freeze from the surface down, turning into glaciers miles deep, but they never freeze solid all the way. Heat from Earth's core keeps some water liquid, like the hidden lakes under Antarctica. This heat is tiny, only about 0.08 watts per square meter. It's just enough for microbes to survive near hydrothermal vents. But not for us. In this frozen world, the last survivors gather around geothermal hotspots like Iceland, drilling into the ground for warmth. But endless blizzards bury whole cities. Scientists have studied what happens to planets that drift through space. One paper, in 2022, explained that when a planet loses its sun, even the atmosphere collapses. Oxygen and nitrogen turn into liquid, then fall as snow. As the last drops of liquid water freeze, the wind carries humanity's final screams. The world turns to ice, and even the air we once breathed is changing. Without the sun's heat, Earth's air begins to collapse. Gases turn into liquid and snow. First carbon dioxide at -78 degrees Celsius, then oxygen at -183 degrees Celsius, covering the ground. The air pressure drops, so breathing becomes hard even before the world freezes. This doesn't happen because of solar wind like on Mars, but because the cold makes the air shrink. Light gases like hydrogen escape, but heavy gases stay close to the ground. Scientists say that within decades, our atmosphere would become only 1% as thick as today. Some tiny life, like tardigrades, can survive in almost no air, but humans would need sealed shelters with nuclear power to stay alive. Imagine a scientist in Antarctica writing the last note. The sky is falling. Our blood would even boil from the low pressure. The question is, how can we fight back? Could humanity survive if Earth was thrown out of the solar system? Maybe a tiny fraction. People might build underground cities near volcanoes or nuclear power plants, growing fungi and bacteria for food. Energy could come from nuclear fission or fusion, like submarines, but adapted for land. Preparation would be key, stockpiling food, insulating shelters, and building power systems. But a bigger question remains: who gets saved? In our story, world leaders try to form alliances, but chaos erupts as riots break out. According to a SETI Institute study, Earth's internal heat alone could keep between 10,000 and 100,000 people alive indefinitely. In the frozen abyss, a spark of human ingenuity flickers, but for how long? Over time, Earth becomes a true rogue planet, drifting alone through the galaxy. On the surface, a frozen wasteland. But deep beneath the oceans, hydrothermal vents could still support strange ecosystems, just like the tube worms we find near volcanic vents today. Why is this possible? Astronomers have already detected more than 100 rogue planets, some even with atmospheres. Earth's magnetic field could still protect against cosmic radiation, giving subsurface life a chance to adapt. In our story, future probes might discover microbial mats evolving into new complex forms. Radiation could even speed up evolution, pushing life in unexpected directions. From the ashes of apocalypse, new life stirs, Earth reborn as a wandering world. But what happens next? Moving at around 100 kilometers per second, Earth could drift for billions of years. Maybe it gets captured by another star system, or maybe it just keeps traveling endlessly. More likely, it drifts alone, slowly cooling until even its core freezes trillions of years from now.